Okay, so this is question number 1, part C. It says, unless otherwise specified, the domain of the function f is assumed to be the set of all real numbers x for which f of x is a real number. And we see we have the definition of f of x here. It is a piecewise function. It says let f be the function defined above. And in part C, it says find the average value of f on the interval from -3 to 4. So we want to recall our average value of a function, 1 over b minus a, the integral from a to b, f of x dx. So we recall our formula and we say, all right, we could substitute into this. We can say that we have an average value equal to 1 over, we would say 4 minus -3, the integral from -3 to 4 for f of x dx. And then we say, well, we want to plug in our f of x here, but the problem is that it's a piecewise function. So we have to split up this definite integral. So our average value is equal to 1 over 7. And we see that the first interval that we have is from -3 to 0. So we're going to say from -3 to 0. And the function that goes with that is the square root of 9 minus x squared dx. And then we will add to that. We see that we go from 0 to 4. And the function that goes with that interval is -x plus 3 times cosine of pi x over 2 dx. And we see that we have two problems that we need to solve now. So on the left side, this integral we see that if we try to use u substitution, if we let u be 9 minus x squared, then du would have to be -2x dx. And the problem is that we do not have any x's on the outside of the radical that we can pair up with dx. It's a missing piece of our puzzle. So we say we can't use the u substitution technique. That's not going to work. And we should be able to look at this radical and say, this is very familiar looking. We've done problems like this. If I say y is equal to the square root of 9 minus x squared, and then I square both sides, and then I move the x squared over, we should recognize this as a circle with radius equal to 3. Now, the radical of 9 minus x squared is a positive radical. There is no negative in front of it. So if we were to graph this, we would only want the top half of the circle. And because the bounds of integration go from -3 to 0, we would only shade this region of it. So we can say that this definite integral is equal to the area of 1/4 times pi times 3 squared, which is 9 pi over 4. This problem was solved strictly using geometry. This is how we started our definite integral units, using geometry as a connection to definite integrals. We would draw different shapes to cover the shaded regions. We would use rectangles to approximate it. And once again, we're using geometry to solve this. If students search for a solution to this integral, they will find something called trigonometric substitution online. That is not what is expected of you. You are expected to make a geometry connection. So we have our first integral equal to 9 pi over 4. Now let's solve our other integral. The integral from 0 to 4 of -x plus 3 cosine of pi x over 2 dx. We can separate this into two integrals. 0 to 4 negative x dx plus 3 times the integral from 0 to 4 of cosine of pi x over 2 dx. And I separated it because the negative x is easy to do. That's just the power rule. So right away we have negative 1/2 x squared from 4 to 0. But the integral on the right needs u substitution. Let u equal pi x over 2. Then du will equal pi over 2 dx. We need to use an adjustment, multiply dx by pi over 2, but now you need to multiply the outside by the reciprocal. So we multiply the 3 by 2 over pi, and we see that we have our second integral now is 6 over pi cosine of u du, because we replaced everything inside with u, and we adjusted it with the pi over 2 so we can replace the dx pi over 2 with du. This is a simple antiderivative now. And the only other thing to do are change the bounds. If I plug 0 into what u is equal to, 0 times pi over 2 is 0. And if I plug 4 into what u is equal to, 4 times pi over 2 is 2 pi. So we can see that we have negative 1/2, 4 squared minus 0 squared plus 6 over pi. The antiderivative of cosine u is sine u. The new bounds for u are 2 pi and 0. Here we have 4 squared is 16 times minus 0 is still 16 times negative 1/2. We get negative 8 plus 6 over pi sine of 2 pi minus sine of 0. Well, sine of 2 pi is 0. Sine of 0 is 0. So all of this zeroes out. The right-hand side integral is negative 8. Let's bring that back up and plug it into our formula here. So we have 9 pi over 4 minus 8. Let's bring that together. 9 pi over 4 minus 8. And then this constant out front is 1/7. And I believe the answer key wrote this as 1/7, 9 pi over 4 minus 8. So they just factored out the 1/7. So you can leave your answer like that. When I worked it out, I got a common denominator and I wrote it as 9 pi minus 32 over 28. Both are correct, but this is what the answer key looks like here. All right, I hope that helps.